So now we'll look into the related problem of Clebsch Gordan coefficients. So this problem is very important, and this will be asked in your semester exam or surely in CSIR examinations. So find the Clebsch Gordan coefficients of spins of electron and proton of a hydrogen atom in the ground state. So we know that where capital J equals capital L plus S, we know already. It is given as ground state. Okay, so for the ground state L equals 0, correct? Because so L equals 0, there will be no orbital quantum number. So there will be no orbital angular momentum. So no orbital quantum number. So there will be no angular momentum. And your J will be S alone. But given the problem is electron and the proton. So the combination of these two. So we'll have to add angular momentum, which we studied earlier. We'll have to go with Clebsch Gordan coefficients. So your J will be Se plus Sp. Se stands for electron, spin of the electron. Sp stands for spin of the proton. Okay, they are all fermions. J1 equals 1 by 2, J2 equal to 1 by 2. Okay, so we know already J1 equals 1 by 2 and J2 equals 1 by 2. So this is for the electron and this is for the proton, or this is for the proton, you can have as electron, doesn't matter. And your J will be lies between J max and J minimum. Okay, we know already the selection rule, which we studied earlier. So your J1 minus J2, 1 by 2 minus 1 by 2, answer will be 0. J1 plus J2, answer will be 1. 1 by 2 plus 1 by 2. So J max will be 1, J minimum will be 0. Is it okay? So now your J will be 0 and 1. So two possible values, very simple one. If J equals 0, M will be 0. Your state will be J comma M will be 0, 0. Correct? Simple one. If J equals 1, your M will be 1, 0, minus 1. So your Jm will be, possibility will be 1, 1, 1, 0, 1, minus 1. So 3 plus 1, 4 basis states are there. 4 bases. Okay, 4 bases. What we call this as singlet, what we call this as triplet. So triple states exist. Single state exists, so single state. Okay. This is okay? Now we will go for uncoupled one. So this is for coupled one. This is for a coupled state. So we have added these two. Okay. Now we will go for the uncoupled state, individual states. So J1 equal to 1 by 2, J2 equal to 1 by 2. If J1 equal to 1 by 2, then for M1 will be 1 by 2 minus 1 by 2. J2 equal to 1 by 2, answer will be for M2 equals 1 by 2 minus 1 by 2. So for the uncoupled basis, this one will be J1, J2, M1, M2. So you will have 1 by 2, 1 by 2, 1 by 2 minus 1 by 2, correct? Then minus 1 by 2, minus 1 by 2. 1 by 2 plus 1 by 2 minus 1 by 2 minus 1 by 2. Is it okay? M1, M2. As I said, J1, J2 will be constant always throughout, as I said earlier. So J1, J2 will be constant. See, actually it should be 1 by 2, 1 by 2, 1 by 2, 1 by 2. J1, J2, M1, M2. Correct? So here also 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. But throughout all the 4 bases, 1 by 2, 1 by 2, J1, J2, it will be constant. So that's why we written as M1, M2. Okay, throughout. How many bases are there? 4 bases for the uncoupled one. How many bases are there? 4 bases for the coupled one. So bases are the same. Only quantum number alone will change. Basis will be the same. Quantum number will change. Okay, that's very important one. Quantum numbers will change. Now, coupled bases. So we know that this will be your total 4 bases for the coupled one, which we already studied. See, which we already seen. So you just add these two, that will give you coupled bases. So this is your uncoupled one. This will be your coupled one. Now we are going to find out the Clebsch Gordan coefficients. So we know the Clebsch Gordan coefficient equation is given by this one. So this is for the uncoupled one, Clebsch Gordan coefficient, and this is for the coupled coefficients. And of course we can expand using the expansion formula. C1 plus C2 plus C3 goes on. So that will be in terms of orthonormal basis. Okay, in the sense, as I said earlier, just take the bra of this one, will give you C1 alone. Take the bra of this one, answer will be C2 alone. Take a draw answer C3 alone. So that's why, as I said, this is orthonormal basis. Okay, now we'll go for the combination. Okay, we'll go for the combination. So 0, 0. Okay, what is the m value? M value is 0. So your m1, m2 must be 0. Correct, m1 plus m2 must be 0. So 1 by 2 minus 1 by 2. Answer will be 0. Minus 1 by 2 plus 1 by 2, 0. So linear combination of these two will give you this. We are going to find out C1. So this will be your C1. Is it okay? Come on, I repeat. Your m will be 0. m1 plus m2 also should be 0. So 1 by 2 minus 1 by 2 is 0. Minus 1 by 2 plus 1 by 2 also 0. So this equation can be obtained with C1. C1 is the first Clebsch Gordan coefficient. And what is this 1, 1? 1, 1. The possibility will be 1 by 2 plus 1 by 2. There is no other possibility at all. See here, no other possibility. So if you want to get 1, you must have 1 by 2 plus 1 by 2. So C2 with 1 by 2, 1 by 2. What of 0? 0. 1 by 2 minus 1 by 2 or minus 1 by 2 plus 1 by 2. Correct? So that will be your C3 for this state 1, 0. This is 0, 0. This state is 1, 0. So you look at this. Almost both. Okay. They are the same. Now we are going to find out C3. What is the next last state? 1 minus 1. So minus 1. Only one possibility exists. Minus 1 by 2, minus 1 by 2. The answer will be minus 1. So minus 1. So we are going to get all the Clebsch Gordan coefficients C1, C2, C3, C4. So they are all Clebsch Gordan coefficients. Now, out of these, the highest state, immediately we can find out this will be your highest state. Taking draw on both sides, answer will be 1. Immediately we can say the highest one. So this will be 1, 1, highest state. And this will be 1 minus 1. Again the answer will be 1 but lowest state. This is 1 minus 1. So this will be your lowest state. This will be your highest state. 1. Second idea is, from the highest state, use lowering operator to come to the next stage. We are going to use the lowering operator. Simple idea. So for the lowering operator, you will have 1, 1. If you use lowering operator, you will have 1, 0. If you use lowering operator for 1, 0, you will get 1 minus 1. Easy. So always you will have to go only with the highest state first. Use lowering operator to get other states. Because very simple idea. So now we are going to use the same method. See 1, 1, C2, 1, 1 by 2 is there. Take draw on both sides. Okay, take draw on both sides. Normalize. You will get C2 star, which is equal to mod C2 square. Answer will be 1. So your C2 will be 1. So we have found out the first component, Clebsch Gordan coefficient, which is nothing but C2 equals 1. We have found out. Remaining C1, C3, C4 are left out. Simple. Okay. Is it okay? Now we will go for the next one. 1, 0. So we are going to, as I said, we are going to use lowering operator for 1, 1. Okay. If you use lowering operator for 1, 1, you will get 1, 0. Simple idea. So J1, 1, 1 will give you, instead of J1 you can write J1 minus plus J2 minus. Correct? There are two charged particles, electron and the proton. We will have to add these two. So J1 minus plus J2 minus. 1 by 2, 1 by 2 this side. So multiply these two, that will give you individual states. Now again use eigenvalue equation for lowering operator. This is your eigenvalue equation. So m goes from m minus 1 and this will be your eigenvalue for j minus. Okay, see, look at this equation. M, here it is m minus 1. So first we will go for left hand side. So left hand side is this one. So you have j1, no, j minus 1, 1 will give you, this will be your j, this will be your m, j, this will be your m. J comma m, j will be 1, m equals 1. So answer will be, this will cancel, 1 plus 1, 2 under root. So that will give you root 2 h bar 1, 0. See, 1 becomes 1, 0. See, 1, 1 becomes 1, 0. All because of m, we have used lowering operator. So m goes to m minus 1. So 1, 0. Now we will go for the right hand side. Right hand side, we will have two terms, this term and this term. So we have j1 minus plus j2 minus acts on 1 by 2, 1 by 2. So this will be your 1 by 2 m1, this will be your m2 1 by 2. So substitute in this expression. So you have 1 by 2 plus 1 by 2, 1 by 2 minus 1 by 2 get cancelled. You have 1 multiplied by 1 by 2 plus 1 by 2, 1. So answer will be 1. Answer will be 1 here. Okay. And what is the second term? This second term. So you have again you have this one will get cancelled. You will have 1 by 2 plus 1 by 2, answer will be 1. So answer will be again root 1, 1. So it is nothing but your H bar. H bar for the right hand side for the first term, H bar for the right hand side for the second one. Very important thing is, very important thing is, for the first one, J1 will act only on M1. Answer will be minus 1 by 2. Don't forget. J2 will act on M2. And so for the second term, this will be minus 1 by 2. 1 by 2, 1 by 2 becomes minus 1 by 2, 1 by 2 and 1, 1 by 2 for M1 and M2. Don't forget. We should not write the same thing. The lowering operator operates on M1 will give you M1 minus 1. So 1 by 2 minus 1. So minus 1 by 2. M2 will remain the same. Here M1 will remain the same. M2 will change into M2 minus 1. 1 by 2 minus 1 minus 1 by 2. Is it clear? Very, very important. So your answer will be, your left hand side will be root 2 H bar which you have already calculated, and right hand side first term and right hand side second term, H bar will cancel. Bring root 2 down, you will get 1 0 1 by root 2 plus 1 by root 2 this term. Is it okay? So we have calculated for the next one. Okay, so this will be your Clebsch Gordan coefficient. So we have calculated for Clebsch Gordan coefficient for this state, 1 0 state. Now lowering operator on the next state, next one, J1 1 0. 1 0 will give me 1 minus 1. Okay, lowering operator. So that will go to the next one. We will calculate now. 1 0 will give you this one, J1 minus plus J2 minus 1 by root 2 this. Is it okay? This is okay. So J1 multiplied by this, J2 multiplied by this. J1 multiplied by this, J2 multiplied by this. Now J1 acts on minus 1 by 2, 1 by 2, correct? Okay, so this one will act only on minus 1 by 2. Suppose if it acts on minus 1 by 2, what will you answer? J1 will act on only on M1. Here M1 is minus 1 by 2. What is the final answer? What is the final answer? M1 minus 1. Minus 1 by 2 minus 1. Minus 3 by 2. Is it okay? I repeat. See, J1 will act only on M1, not on M2. So if it acts on minus 1 by 2, the answer will be M minus 1. M1 minus 1. So already minus 1 by 2 is there. So minus 1 by 2 minus 3 by 2. Minus 3 by 2 state is not here. So answer is 0. There is no state minus 3 by 2. Look at the combination, 4 combinations. We don't have any minus 1 by 2. See, we have only 1 by 2 alone. Here we have only this much alone. We don't have any 3 by 2. So the answer will be 0 here. Is it okay? Now similarly, J2 acts on 1 by 2. Similarly, J2 acts on minus 1 by 2. Again, minus 3 by 2. So this term will be 0. This term will be 0. So we should have only this term and this term alone. So we can have only this term and this term alone. Is it okay? So out of these two terms, we have reduced to 1 using the possibility selection rule, M1 minus 1 and M2 minus 1. We have obtained this one. Now J1 acts on 1 0 will give you, use the same eigen formula, you will get root 2 H bar 1 minus 1. See here 0, the state will go from 0 M1 minus 1, so 1 minus 1. This is for the left hand side. Is it okay? See 0, the next step will be m minus 1. See, the answer will be minus 1. 1 0, here it is 1 minus 1. What about the right hand side? Right hand side. So you will have 1 by root 2 right hand side. Just use the formula, the same formula which we have used. Same formula. So you will have 1 by root 2, 1 by 2 plus 1 by 2, you will have this one with the state, and this state, the eigenvalue for the next one, right hand side, second term of the right hand side, you will get this. Okay, so this is for the left hand side and this is for the right hand side. You just add these two, these are all common, so you just add these two, that will give you 2 divided by root 2. You bring this root 2 down, 2 by root 2 multiplied by root 2, that will be 2, so 2 by 2, answer will be 1. So answer will be this one. So the coefficient is 1. Okay, the coefficient is 1 here. So now the lowering operator operating on the last state also will give you this. So we have already calculated 1, 1, 1 by 2, 1 by 2, the coefficient is 1, 1, 0, this one, okay, 1, 0, the coefficient will be 1 by root 2, 1 minus 1, the coefficient is 1 here, 0, 0, the coefficient will be 1 by root 2. You just see here, this is exactly similar, but here it is plus and this will be minus here. Okay, this is plus and this is minus. Is it okay? Okay. So now we will go for, so now this is plus and minus. So first we will calculate for 1, 0, 1, 0, 1 by root 2, 1 by 2 minus 1 by 2, minus 1 by 2, 1 by 2. And we know that 0, 0, so 0, 0. Okay, 0, 0 is given by, we do not know. Okay, so that's why we are going to insert now A, B, we are going to find out what is the value of A and B. So A 1 by 2 minus 1 by 2 plus B minus 1 by 2 minus 1 by 2. You just take, multiply these two. Multiply these two. You are going to multiply these two, your left hand side is exactly like this. Right hand side, you have to multiply this one, this. Alright, this one, this. Then you have to multiply this and this, you have to multiply this and this. Okay, if you multiply this and this, answer will be 1. If you multiply this and answer will be 1. If you multiply this one, answer will be 0. If you multiply this, answer will be 0. This alone will exist. This alone will exist. You will get A by root 2, here also B by root 2. So this is answer will be 0, orthogonal property. So your A by root 2 plus B by root 2. Okay, so there are two possibilities. A by root 2 equals minus B by root 2 or B by root 2 equals minus A by root 2. So there are two possibilities. Okay, we will see one by one. A by root 2 equals minus B by root 2. We will see one by one. So it implies that A equals minus B. Okay, so before that, so we will go with this one. Just take the normalization. So normalization will give you, answer will be 1. If you multiply this, answer will be 1. If you multiply this one, state will be 1. Multiply opposite, answer will be 0. So you will get A square plus B square, answer will be 1. Now A equals minus B. So A equals minus B, answer will be 2B squared equals 1. So B equals 1 by root 2. If B equals 1 by root 2, the answer will be A equals minus 1 by root 2. Now suppose if you write on the other way around, minus A equals B, you will get, substitute here, you will get 2A squared equals 1, correct? There are two possibilities, A equals minus B. You will have 2B squared equal to 1 for the first case, and for the second case, 2A squared equals 1. You have A equals 1 by root 2, B equals minus 1 by root 2. See, look at the sign, A equals minus 1 by root 2, B equals minus 1 by root 2. Here A equals plus 1 by root 2, B equals minus 1 by root 2. Here A equals minus 1 by root 2, B equals 1 by root 2. Whichever value we have to take. Okay, either we can take this combination or we can take this combination, which goes like this. The way is 0, 0, 1 by root 2. If it is positive, just take positive value. Okay, here 1 by root 2 is positive value. Just take the positive value. For A, this must be positive value. A equals 1 by root 2. This is negative value. Okay, just take the negative value. That's all. B equals negative value. Is it okay? See, we have two combinations for A and B. Okay, depending on, you choose, if it is a positive value, just take positive value. If it is a negative value, choose negative value. So now we have found out the A value and B value. Okay. Now, as usual, the matrix form of Clebsch Gordan coefficients. So this will be your coupled one. This will be your Clebsch Gordan coefficients, and this will be your uncoupled one. So we have transformed from uncoupled to coupled through projection vectors through Clebsch Gordan coefficients, which we have written the matrix form, which is nothing but this one. So these are all Clebsch Gordan coefficients for the ground state of electron and proton, which you have found out. Can you remember all the things? 1 by root 2 minus 1 by root 2, all those things. As I said earlier, we will have to transform from one basis to another basis, as I said earlier. Okay, from one basis to another basis, and we will have to use only unitary transformation, which you have used for the pictures. Unitary transformation. The main property of unitary transformation will be U inverse equals U dagger. You are going to change the rows into columns, column into rows, and take the complex conjugate. Transpose and complex conjugate. Complex conjugate and transpose. But all you have only real values. See here, all you have. We discussed already that all Clebsch Gordan coefficients will be real values. See, all are real values. So we can transform from here to here. This is your, suppose if we consider this is your U. U inverse. U inverse multiplied by this one will give you uncoupled one. So this will be your U. Unitary transformation. Okay. Now we can have U inverse. Exactly. U inverse like this. That is, you how to take U inverse? Just rows into columns. See, just rows into columns. See here, we have row, first row. See, this will be your column. This will be your second row. This will be your column. See, this is your U dagger, correct? U inverse, U dagger. I have changed. See, I repeat, this is your U. Suppose if I bring U here into left hand side, this will become U inverse. U inverse is nothing but U dagger. Just U dagger multiplied by this coupled one will give you uncoupled basis. So uncoupled basis will be U dagger multiplied by coupled basis. So this is your coupled base. Okay, totally. The answer will be coupled basis. Okay, so second row, second column, third row, third column, fourth row, fourth column. So that's it's very simple one. Okay, any doubt? So this problem is very important, and we have used Clebsch Gordan coefficients to get the ideas from uncoupled basis to coupled basis. Okay, thank you students. We'll see you later.